Question 6.4. An amide link is also formed when an acyl chloride reacts with a primary amine. So here's an acyl chloride. It's got a COCl, a C double bond O and a Cl. And a primary amine's got an NH2. The N is bonded to one C. So what happens? Well, an acyl chloride reacts very violently. It's a dangerous chemical. It's very corrosive and reacts with other chemicals to make HCl, hydrogen chloride gas, which appears as white steamy fumes. It reacts too violently, really, for it to be sometimes safe to use. So we've got to be very careful when we use acyl chlorides because it reacts very, very vigorously, very, very violently. So what actually happens is, well, the COCl, it loses the Cl from this end, which reacts with an H off an NH2. So it's going to make CH3CH2CO. The Cl and the H come off, and then there'll be left an NH, a CH2 and a CH3. And the amide link, the CONH2, will be in the middle. Let's have a look at the mechanism, and then we can work out the name of the organic product formed. So what actually happens is, the primary amine has got a lone pair of electrons on the N and it bonds to the C. Now a common mistake is that you think the Cl comes off first, but it doesn't. The double bond breaks and the O accepts the electrons. I sometimes call this, jokingly, a loan shark, because what it does is it says, I'll help you out, and it helps out by breaking that carbon to oxygen double bond and makes a single bond, but then it wants to reform it again in the next step. So it helps out and then reforms it again in the next step. So in the first step, the NH2 is bonded onto the C. The C double bond O has broken and left a single bond, and the pair of electrons from the bond has gone onto the O. The O becomes minus because it's had an arrow going onto it, it's had electrons going onto it, and the N becomes plus because that's had electrons moving away from it, an arrow going away from it. The NH2 I've drawn as a displayed formula now with two H's, and then the CH2CH3 rather, here. Now, I've got to have three arrows. I mentioned about the O sort of helping out, breaking the double bond to leave a single, so that the carbon still has four bonds here, doesn't have too many bonds. But now the pair of electrons, and it's the arrow from the pair of electrons, goes back into the bond to reform the carbon to oxygen double bond. At the same time, the bond from the CCl now breaks to make Cl minus. That will make a Cl minus, and the Cl has gone from here now. And an H breaks off as well, and the electrons from the NH bond, it can be either of these two NH bonds, goes onto the N to remove the plus charge and to release an H plus, and the H plus and the Cl minus will make HCl. The N loses its charge because it's had electrons moved onto it, and it's now only got NH and then CH3CH2. It's called addition elimination because first of all everything adds together, and then secondly atoms and molecules are eliminated, removed. We've lost a Cl and we've lost an H, which will come off. And so I've made this chemical here. How do I name it? So I name it because I look at the N group and I name what's on the N group, and that's an ethyl. It's not a CH3, it's a CH2CH3. So it's not a methyl, a CH3, it's a CH2CH3, it's an ethyl on the N. So I call it N-ethyl to show the position of the ethyl, because the ethyl could be somewhere else, like here. But it's not, it's actually on the N. N-ethyl. Then amides end in amide, and I count the number of carbons. 1, 2, and I count that 1 there as well. 3, propanamide. I drop the E, otherwise it would be propane amide, and I'd have two vowels together.